Today we're looking at section 5.5 on the Fibonacci sequence and golden ratio, and we'll be working some example problems from the textbook starting on page 216. So number 2 says, recall that f sub n represents the Fibonacci number in the nth position of the sequence. What are the only two values of n such that f sub n is equal to n? Okay, so let's recall. First few places through the sequence. Let's see, that's 8, 9, and so forth. Okay, so we have, notice 1. F sub 1 is 1, so that's one of them. 1, 2, 3, 4, 5. This is the other. F sub 5 is equal to 5. Okay, and number 4, if two successive terms of the Fibonacci sequence are both odd, is the next term even or odd? Okay, if we add two odd numbers, for example here, 13 and 21, we get an even. 3 and 5, we get an 8. And that's going to happen every time. If we add two odds, we're going to get an even. Okay, number 6. What is the approximate value of the golden ratio to the nearest thousandth? Okay, they talk about the golden ratio on page 214, and you'll notice that the exact value is 1 plus the square root of 5 divided by that whole sum divided by 2. So if we use our calculators to approximate that value, I want to take 1 plus the square root of 5, and I'm going to hit equals, and then I'm going to divide that answer by 2. I get 1.6180. They want it to the nearest thousandth, so it would be 1.618. Because it's a 0 to the right, we're just going to drop the remaining digits. Okay, now we have some patterns to work on. In number 8, we have 1 equals 2 minus 1. 1 equals 2 minus 1. We're looking for a pattern as it relates to the Fibonacci's. 1 plus 3 equals 5 minus 1. 1 plus 3 plus 8 equals 13 minus 1. 1 plus 3 plus 8 plus 21 equals 34 minus 1. And I'm going crooked here. Okay, and then 1 plus 3 plus 8. 8 plus 21 plus 55 equals 89 minus 1. So what they want us to do is use this pattern to find the next one in the sequence. Okay, so we're going to copy everything we have on the left. Now, if we look, we're doing 1, 3, 8. Okay, it's a question as to which one, so I think it's this one just based on, get rid of that. Looks like we're doing every other one, 21, 55. So the question is, what comes next? We have 89 plus 55. It's going to be 144, it looks like. So plus 144 would be the next one. And 89 plus 144 is 233. Okay, 233, I'll carry it out down here, and 144 plus 233 is 377, and so forth. Okay, so let's see. All right, so 144 would be the last one in the sum. Now, how do we get started with 2, then the next one was 5, then 13, 34, 89. So the next one should be 233 minus 1. Okay, so 233 minus 1. So this entire thing here is our answer. Okay, let's see if we can do one more of these. Let's look at number 10. We have 1 squared plus 1 squared is 2. 1 squared plus 2 squared is 5. 2 squared plus 3 squared is 13. 3 squared plus 5 squared is 34. 5 squared plus 8 squared is 89. Okay, so it looks like they're taking them in sequence. They start with 1 and 1, and then 1 and 2, and then 2 and 3, and then 3 and 5, 5 and 8. So the next pair would be 8 and 13. So 8 squared plus 13 squared. Now, where are they getting the other numbers? Let's see, we have a 2, then we have a 5, then we have a 13, then we have a 34, then we have an 89. Looks like they're taking every other number, so our next one would be 233. And that's easy enough to check with your calculator to make sure that it is true. 8 squared plus 13 squared does equal 233. So we're looking for patterns here. A lot of math can be solved by looking for patterns. Okay, I think that's enough on 5.5, so you can go ahead and do the homework for that in my math lab.